Okay, when we were near the end of class, we were working on C part, and it was the cosine of the cosine inverse of pi. So you had to match it up to the three rules that we put on the board, and the cosine of the cosine inverse matches up with this one. And for that rule, x, this was equal to x, and x was restricted between -1 and 1. So this problem fits this rule, which means that, let me make that be the generic rule there. Cosine of the arc cosine of x equals x if x is between -1 and 1. That means that our problem, x is pi. So we're going to say, is pi in this range here? Does that work for x? Is pi between -1 and 1? Well, no, pi is about 3.14 rounded. That's too big. So it's not in that range. So then in class I was saying, but what about coterminal angles? So a coterminal angle for pi is pi plus 2 pi. We find coterminal angles by adding or subtracting 2 pi. Well, that puts it at 3 pi, which is even bigger. It's even more outside of the range. Well, what if you did pi minus 2 pi? That puts you at negative pi, which is about -3.14, and that's too little. That doesn't fit in this range either. So this one, we tried to make it fit. It didn't fit. We did the coterminals. It still didn't fit. This does not exist. We cannot do that. Alrighty, now let's do example 7. And it says find the exact value A part is the tangent of the arc cosine of 2/3. Well, I think you probably see immediately that this is different. It's not the tangent of the arc tangent. It's the tangent of the arc cosine. So what we're going to do is this U strategy. We're going to let U be the arc cosine of 2/3. So then I'm going to rewrite that as tangent of U. So I'm replacing arc cosine of 2/3 with U. So then let's think about what this means. This means that the cosine of U is 2/3. We're going to go and draw a little right triangle, put U in an angle, and put the A and the H where they belong. We'll do the Pythagorean theorem to find the missing side. A squared plus B squared equals C squared. And I believe we are always using the positive root here. So B is square root of 5. And then it's simply as easy as finding the tangent of U, which is TOA. So it's the O side over the A side. Okay, let's see another one. B is the cosine of the arc sine of -3/5. So immediately you notice again, this is another one of those weird problems because it's the cosine of the arc sine instead of the cosine of the arc cosine. So we'll do the U step. We'll say U is the arc sine of -3/5. That means we're going to be finding the cosine of U. So if U is the arc sine of -3/5, that means the sine of U is -3/5, and we'll make a U triangle. Put the U, sine is O and H is always positive. And we'll do whatever we need to do to find the A. Pythagorean theorem. A is 4. Now we have our U triangle completely filled out, and we can go back to this problem and find the cosine of U using CA. And that's our answer. Okay, I remembered something when I was looking at the book. I don't need to be quite so sloppy in just drawing this U triangle. I need to think about where it's at. And I need to think, since we're doing cosine, arc cosine, we're in these two quadrants. And the cosine is positive. And if you look at your positive x, it's positive in these two quadrants. That means this triangle that we're talking about actually sits right here. That's the only quadrant that satisfies arc cosine and positive x. So this is U, and this is 2, and this is 3. So when we got to this step and we're trying to decide right here, do I need the positive or the negative root of square root of 5? This is a positive y value. That's why we choose the positive root. Same thing over here. I don't need to be so sloppy. I need to be thinking about arc cosine. We're doing arc sine, we're doing arc sine, which is in these two quadrants. And then we look right here, and we have a sign that's negative. So you do your positive x. Sine is negative here and here. So this is the quadrant where we need to sketch our triangle. And remember, it always goes perpendicular to the x-axis, and the angle is always at the origin. So if the sine is negative 3/5, it's opposite hypotenuse, and hypotenuse is always positive. So then when we get to this step right here and we're trying to decide, is it positive or negative 4, you look at this segment of the x-axis and you say, yes, that is a positive value. So that's why we choose that. Okay, that's it for this.